Hello everyone, welcome to Learn Reality Consult. Ladies and gentlemen, today I'm going to give a brief lecture on this important topic, and that is Introduction to GIS Mapping. Examples of geospatial data. Let's get started. What is spatial data? More than 80% of all information in society has a spatial reference, meaning that about 80% of information in society has a geographic point with reference to the surface of the earth. Spatial data is data with a direct or indirect geographic reference to the surface of the earth. Spatial data is an indispensable part of the basic infrastructure of a country, as are roads, hospitals, and schools, meaning that spatial data is very important to the fabric of the society, just like roads, hospitals, and schools. Spatial data is strategically important to decision makers at all levels, especially to real estate practitioners, people that will deal with real estates. This data is very crucial to them. So, application areas for geospatial data. Geospatial data can be applied in climate change, population, elections, political and social conflict, local government, loss of biodiversity, managing natural disasters, and then water security, natural resources. Can also be used in economic uncertainty, urbanization and land use, human health, national security, technology advancements, transportation, globalization, as well as land administration. These are applicable areas for geospatial data. So, what data can be used to map things? We've already talked about what geospatial data is. Now, it is important to note what data can we use to map things. It's a question to all of us to ponder on. And one of the data that we can use to map things is latitude and longitude. We can use longitude and latitude. That's probably the first one that comes to mind. If we have coordinates for a given location, we can reference those to the surface of the earth and describe pretty much anything we want. That is it. Latitude and longitudes can be used to map things. Let's move on. Street addresses can also be used to map things. You may also think of street addresses. So if you type a street address into a web browser, then you can use to map things. For example, let me demonstrate it by using Google Maps. And let's say we want to find the location of one of the streets that was on the PowerPoint, which is George Walker Bush High Street. When you click on it, this is George Walker Bush High Street, this one. So indirectly or directly, we have mapped the street of George Walker Bush. So, streets can be used to map things. Postal codes can also be used to map location. So, the post office using that one to decide how to deliver mail to someone. Assuming that you purchase something from an online like Jumia, like AliExpress, This postal code can be used to send that parcel or package to you. So that code can be used to map things. And it's also important to know that area codes can be used to map things. Here we have example of a bunch of them for different locations. You see them? Different locations. Some of them are very large. You see this one very large. This one is very large. And some are very small. So if you tell somebody the area code for your phone number, they will be able to map you within that location. So all of these are examples of geospatial data, ways of being able to put something on the map. This is the area codes. And zip codes can as well be used to map things. So when we think of what a GIS can do, what can GIS do? It can certainly map locations so that is the where it is. Mapping location, showing where a property object is. So these are location of buildings and roads and other objects. You can also map or store attributes, which is what it is. Attribute is what it is in relation to the object, where it is, the location. And it's also very crucial that relationships can also be stored in relation to locations. This is equals A is the same as B. A is the same as B. See it? We have touches. A touches B, meaning the boundaries touch each other. A boundaries touches B boundaries. You see it? And this is where the boundaries touch. And the overlaps. That A and B have multiple points in common. Yeah, multiple points in common. Contains A contains B. So B is found within A. The strength, A shares nothing with B, meaning the boundaries do not touch. There's a separation between A and B. Covers, A covers B, and vice versa. And that is it. And then crosses, A and B have at least one point in common. So we can demonstrate this by using ArcGIS Online. By using ArcGIS Online. Our ArcGIS Online. Here we can see how in ArcGIS Online we can store and access location and attributes. This layer is a hurricane evacuation route, and this is Hastings census tract demographics. Hastings census tract demographic. So let's zoom in on the map. This is when you click on census and you click on height table, the attribute table will not be displayed. When you click show table, the attribute table is displayed. So let's explore our data. This is the attribute. This is Hastings Census Tract Demographics Features. 1492. Total population 2019. Population under 15 2019. Population 65 plus 2019. Percent of household with income below poverty level. And then we have owner stroke renter household without a vehicle 2013 to 2017. This will enable planners and people that will rescue the people of Hastings in case of emergency like hurricane. Those that do not have vehicles can be easily evacuated. Then we have percent of household without a vehicle, that is total owner renter households. And then so when you click on this, you see the attributes appeared on the map. That is total household 1004, total household 1499. So out of this, a household with a vehicle is 264. 17.61% of households in this tract do not own a vehicle. So let's give some kind of symbology to this households without vehicles. So click on Hastings Census Tract Demographics. Click on Change Style. Pick this percent of household with owner renter household without a vehicle. Click on this and wait. Counts and amounts color. And click on this. Click on done. So we have highlighted household, percent of households without vehicles. See that? So where it is, and then what it is, that's the relationship. Where it is, that's the location, and what it is, what is that location. So at this junction, we can also perform some kind of spatial analysis, maybe an overlay analysis like buffers, to see a distance of households with a vehicle to a particular location. So let's click on analysis, use proximity, create buffers. Let's make a distance of 2 kilometers. Graphics. Buffers of her census result layer name for the analysis to be completed. Yes, Voila, the buffer has been completed. The buffer has been completed. So basically, these are examples of what we can use to map things. So if you enjoy my videos, kindly leave a comment below and subscribe to my channel. Thank you very much.